Running a load test manually once a quarter, or once before a major release, is better than nothing, but let us be honest about what it actually is. It is a point-in-time safety check, not a continuous safety net. And the problem with point-in-time checks is that performance regressions do not respect your release schedule. They happen when a developer adds an inefficient database query on a Tuesday afternoon. They happen when a dependency update changes the memory allocation behavior of a third-party library. They happen when a configuration change accidentally disables connection pooling. They happen when a new feature introduces an n+1 query pattern that nobody noticed because the test dataset was too small. They happen incrementally, sometimes invisibly, accumulating across dozens of small changes until suddenly something that worked fine last month is noticeably slow this month and nobody can identify exactly when or why it changed. The solution to this problem is the same solution the industry applied to functional correctness 15 years ago: automate the testing, run it on every code change, and make failures visible immediately. In this episode, you are going to learn how to integrate load testing into your CI/CD pipeline using K6 and GitHub Actions so that performance regressions surface before code merges rather than after it ships to users. Let me start with the core argument for why CI is exactly the right place for performance testing. The earlier in the development cycle you catch a performance regression, the cheaper it is to fix. This is not a vague platitude, it is a measurable reality. A developer who introduces a slow database query, maybe they added a missing where clause filter, or they are loading an entire table to filter in application code instead of in the database, can find and fix that problem in 20 minutes if they see a failing load test step in their pull request before the code merges. If that same query reaches production, you are looking at a different kind of incident entirely. Identifying the regression, rolling back or hotfixing, writing the postmortem, implementing the fix properly, that is easily a day or more of engineering time, plus whatever user impact occurred in between. Performance regressions caught in CI cost almost nothing to fix. Performance regressions caught in production are expensive in time, reputation, and sometimes revenue. Here is how to set up the GitHub Actions workflow. In your repository, create a file at .github/workflows/loadtest.yml. Set the trigger to run on pull requests targeting your main or master branch. Define a single job with an appropriate runner. Ubuntu latest works well. Your first step should check out the code using actions/checkout. Your second step installs K6 using the official Grafana/setup K6 action from the GitHub Marketplace. This handles the installation cleanly without any manual scripting. Your third step runs your load test with K6 run followed by the path to your test script. Because you have defined thresholds inside your K6 script, response time under 500 milliseconds at P95, error rate under 1%, K6 will exit with a non-zero status code if any threshold fails. GitHub Actions interprets a non-zero exit code as a failed step, which fails the job, which can be configured as a required status check on your branch protection rules. No code merges if it degrades performance. The setup takes maybe 30 minutes the first time and then runs automatically on every pull request forever. Not every type of load test belongs in CI, and getting this wrong can make your pipeline slow and painful. Your CI load test should be short, 2 to 5 minutes maximum. It should use a realistic but not extreme virtual user count, something close to your normal production traffic level rather than your breaking point. It should focus specifically on your critical paths, user authentication, your primary API endpoints, any transactional flows like checkout or payment processing. And it should have well-defined thresholds with clear pass/fail behavior. Long-running tests absolutely do not belong in CI. A soak test that needs to run for 6 hours would block every pull request for 6 hours, nobody will tolerate that, and the test will get disabled within a week. Instead, schedule your soak tests as a separate nightly workflow using a cron trigger in GitHub Actions. Set it to run against your staging environment at 2 a.m. when no deployments are happening. Schedule your full stress test to run weekly or as part of your release pipeline on a dedicated staging environment. This way you get fast feedback on every PR and deep analysis on a schedule, without either one compromising the other. There is one practical challenge with load testing in CI that you need to address upfront: your CI environment is not production. Your staging server has less CPU and memory. Your test database has a fraction of the data volume of your production database. Your CI runner itself has variable performance depending on what else is running on the underlying host. This means the absolute numbers you see in CI will be different from what you would see in production, and that is completely fine because you are not trying to reproduce production numbers. You are looking for regressions relative to your own baseline. The approach that works is this: establish your baseline by running the load test on your CI environment on a known good commit and recording the results. Every subsequent run compares against that baseline. A 20 or 30% increase in P95 response time on the same code path is a meaningful regression worth investigating, even if the absolute numbers look different from what production would show. For trend analysis over time, use K6 JSON output option to save results as a CI artifact on every run. Over weeks and months, you will be able to see exactly when performance shifted and correlate it with specific commits. Automated performance testing in CI is one of the highest leverage investments a QA team can make, and I want to emphasize the leverage aspect specifically. The upfront cost is real but bounded: a few hours to write the test script, set up the GitHub Actions workflow, establish the baseline, and tune the thresholds. That is a one-time cost. The ongoing benefit is continuous, permanent protection against performance regressions on every single code change from that point forward. Developers get performance feedback as a natural part of their pull request workflow, without any additional effort from the QA team after the initial setup. Performance stops being something that someone has to remember to check and becomes something that is automatically checked on every change. That kind of structural improvement to a team's process is rare and valuable. Most quality improvements require ongoing human effort to maintain. This one pays dividends automatically. In the final episode of this series, we are going to focus on the communication side of load testing, because the best test results in the world accomplish nothing if they are not communicated in a way that drives action. We will cover how to write a performance test report that engineers prioritize and that managers understand, with concrete examples of what good looks like. See you in the next one. One last thing I want to cover in this episode is how to handle the conversation with your team when you are first introducing load testing into CI. There will be resistance. Some developers will see a new required pipeline check as a slowdown or an obstacle. Some will argue that the CI environment is too different from production to make the results meaningful. Some will question whether the threshold values you set are correct. These are all legitimate concerns, and you should engage with them directly rather than dismissing them. For the environment difference concern, acknowledge it is real. Explain that you are looking for regressions relative to a consistent baseline rather than absolute production numbers. For the threshold concern, start with conservative thresholds that are clearly achievable and tighten them over time as you build confidence in the baseline. For the slowdown concern, keep your CI load test under 5 minutes, which adds less time than most people spend in their daily stand-up. Frame the conversation not as adding a gate but as adding a mirror, giving developers visibility into the performance impact of their changes before those changes reach users. That framing tends to land much better than presenting it as a quality enforcement mechanism, even though it is both.